We're going to be going through lesson 4.5 today. And the first thing to notice is what we're trying to do. We're trying to move from an original f graph to a first derivative graph. But the approach we use here will apply just as readily from a first derivative graph to a second derivative graph. These are purely estimates, so don't try to get the slopes exactly. Example 1 is a really good example. They give you the first original function right here, and they're asking you for the first derivative function. Now the thing to know about first derivative function is that the y-axis is describing the slope of the original function. So every y value here in this graph is matching the slope as an estimate of this function. The first thing I'll want to do is identify key spots on the original function. So I identify the endpoints. I identify where I have a max or a min, and then I show where a point of concavity has changed. Let's start first of all with the maxes and the mins. I know that at -2 I've got a max. The slope of that max point is 0. So if I'll go to -2 right here, I'll show a value of 0. Remember, the y value in this graph is matching the slope value of the original graph. I do the same thing for +2. Look at what that particular slope is. It's 0. So at +2 on the f prime graph, I'm going to have a y value of 0. Now as I look at what the slopes are doing going up to this max, they're all positive, but they're getting a little bit less and less steep. Therefore, I want to show on my f prime graph these function values, which are derivative values, are getting less and less and less in value because the y value here describes the slope right here. So the slope at this spot is pretty steep. I show it as fairly high, and that's purely an estimate. And then as I get to the top, I'm heading down to 0. Now all my slopes from here on are negative. Notice that I'm getting more and more steep until I come to the steepest point of all, the greatest negative slope. I'm going more and more steep until I get to the greatest negative slope value, which is the y value here. Then my slopes begin to flatten out more and more, the tangent lines, until I reach 0. So I'm still showing negative y values to express the slope, but as I get closer and closer to the x value of 2, I'm approaching an ultimate slope of 0. From there on, all my positive values here represent, and by positive values, I mean the slope values, all my slope values there are going to represent positive values on this graph right here, because every y value here is a slope value here, and I'm going from 0 to a pretty steep slope, from 0 to a higher and higher y value. The steps right here describe what to do if you want to move from f prime to f. You should take a moment to read those, and after you have and underlined any key ideas, then restart the tape and I'll cover number 2. In number 2, we're moving from a derivative graph all the way back to the original graph. So the first thing I'll want to do is I'll want to mention or show where the starting point is. A starting point is just a reference point to get you going. So I'm going to show this starting point by circling it. I circle my endpoints just to be able to find them. And then I'm going to circle key other points or box them in. And that's going to be this value or max value of f prime. Now keep in mind, the max value of f prime is not the max value of the original function. This is really saying that I am at my steepest slope because the y value here is describing the steepest slope of the original graph. And so I begin to notice that all my values here are describing positive slopes between about -3.5 to 0. And I want you to notice from about the same location here all the way to 0, all these have positive little tangent lines. Also notice that my slopes here and here are 0, and so the slopes here and here are also 0. I could put a little tangent line there, a little tangent line there that has a slope of 0. This describes the most steep slope of the original graph because this y value is the greatest, and this y value is the slope of the original graph. So I estimate what that is, about 1.5, maybe 1.3, and I'm going to show a little slope line right here that approximates that. You're not going to get it exactly, but I want to show that it's positive, and I want to show that I have the steepest slope here as opposed to here and here. I repeat the process for this, showing the most negative slope at 2. I move over to 2, and I'm going to show a little tangent line right here, and that'll give me the steepest slope. If you just draw little tangent lines to help you describe this original graph, then connect the tangent lines, you should get a pretty good slope. You can see I also used a slope line indicator here where I show f prime is positive all the way to 0 and then f prime is negative all the way out from 0. So I'm going to show that all these slopes on this side of the original are going to be positive and all the slopes on this side are going to be negative. Now I want to point out just one thing here, and that is we're going from f prime to f, and that shows f double prime, and that's actually not to be looked at. So this is going to be your original graph. Now what happens if you want to go from f prime to f double prime? To do that, I'm going to have to do the same process I used up above. I highlight the key areas, and then I treat this f prime graph as an original graph, and from that I can say the slope is 0 right here, the slope is 0 right here, and then I can begin to construct the second derivative graph, which will look very similar to this graph right here that we had above. Example 1 and 2 should get you going on the rest of the assignment. You can see the solutions down here for the remainder for number 3. Notice again this is an f double prime graph. We're going from f double prime to f prime. It's the same process as going from f prime to f. So just treat these as a derivative of this function. Then after you've done this function translation over here, ignore that f double prime, look strictly at this graph, and then you can figure out what the original graph is, again, using the same process you used for number 2 above. Good luck on the homework, and work well in groups. I'll see you guys on Wednesday.